So in the pair pass game from the previous video, the equilibrium was clearly suboptimal for both players. Patrick ended up with a negative payoff, and Dan only ended up with a payoff of one, despite being the first mover. What type of changes to game structure might allow players to reach a more efficient outcome? One of the options is a side payment. The key is for players to use strategic moves. A side payment is an example of this. It's just an action that's taken early in the game that favorably influences the ultimate outcome of the game. So, side payments, it's just a simple strategic move. It's a bribe that influences the outcome of the game. So, let's go back to our player pass game. Dan has no incentive to pass because Patrick will always play, leaving Dan with nothing. So how might they reach a better outcome through side payment? Well, Dan could offer to pay Patrick to pass rather than pay. So suppose Dan promises to pass and give Patrick a side payment if Patrick will pass too. How much does Dan need to promise in order to guarantee this outcome? Let's see in the game. So this is the original situation that we had. Dan has the option to play or pass, and then if Dan passes, Patrick can choose to pay or pass, play or pass. Uh, so ideally, we would both end up here with Dan playing pass and Patrick playing pass. Uh, but because Patrick would receive a higher outcome, a higher payout if he played, uh, you're never going to end up in that situation because Dan, knowing that Patrick would play, would be choosing between a payoff of 1 and 0, and so he would choose 1. And that's how we ended up with this equilibrium down here. However, if Dan offers Patrick a side payment of 2 in order to guarantee that Patrick chooses pass, how will this change the outcome? We're going to change the payoffs up here. So Dan gives 2 units, so we have to subtract 2 from 11. So Dan's new payout is 9, and he gives those 2 units to Patrick. So Patrick has 11 plus 2 with a payout of 13. Now Patrick is choosing between 13 and 12, so Patrick will choose to pass. Now Dan is choosing between 9 and 1. He'll choose the 9, so we have a new equilibrium of pass, pass. So this side payment of 2 changes Patrick's best response to pass, and so the new equilibrium is pass, pass. The problem with this, though, is that even if these side payments sound like a good idea, it might be difficult to reinforce or guarantee them uh, or prevent players from reneging on them. Commitments that aren't enforceable are all often referred to as non-credible threats. These are just empty threats or promises made by one player in a sequential game. So to avoid this dilemma, a player has to make a credible commitment. This is just a signal that a signal to a player's opponent that the threat or promise is credible. So let's look at an entry deterrence game. This is where we apply the concept of credibility. This is a common application in microecon for strategic moves. This is just a firm deterring other firms from entering into a market. So consider the market for tablet computers. Assume Apple is the only one making tablets, but Samsung is thinking about entering into the market. What does Apple have to do in order to prevent Samsung from entering? Well, first, they could threaten a price war. But threatening a price war is different than actually engaging in a price war. So Apple has to do something to make sure that threatening the price war is a credible enough threat to prevent Samsung from entering the market. So we have this entry game. It looks a lot like our player pass game. And that shouldn't come as a big surprise. Samsung moves first. They're choosing whether to not enter or enter, and Apple is choosing whether to fight them in terms of competition or not fight them. So Apple has promised to fight a price war if Samsung enters the tablet market. Is this a credible threat? Let's look at the payoffs. If we look at the payoffs for Apple, we can determine this is not a credible threat, as the payoff for not fighting is higher. Therefore, Samsung will choose to enter, and Apple will choose not to fight. If you were solving this game backwards, you would see, in this case, Apple is choosing between 0.8 and 1. They're going to choose 1. They're choosing not to fight. So Samsung is choosing between 0.5 and 0. They'll choose 0.5. And so the equilibrium ends up being Samsung enter, Apple don't fight. What about credibility applied? A common application of strategic moves is deterring other firms from entry. Again, consider the market for tablet computers. Rather than threatening just a price war, Apple could invest in excess capacity in anticipation of Samsung entering, putting itself in a better position for a price war. So Apple makes investments that make their commitment to a price war more credible. So we have the same game again. This time, Apple has invested in excess capacity, lowering its cost of engaging in the price war. This time, is Apple's threat of a price war credible? Let's look at the payoffs. Starting from backwards induction, you have Apple choosing between 0.8 for fighting and 0.6 for not fighting. So Apple will choose to fight. Therefore, Samsung is choosing between negative 0.5 and 0. So they'll choose 0. Samsung chooses not to enter, and that will represent the Nash equilibrium. So Apple's investment in excess capacity effectively prevented Samsung from entering. The threat that they made was credible because of investments that they made before the game started. To wrap up, game theory gives us a logical framework in which to understand opponents' likely responses to your decisions. This is a framework that's useful in many strategic situations, not just market cases. We saw a lot of market examples in this chapter, but we also saw the soccer example, and there are many, many, many other interpersonal contexts in which we can use game theory to figure out optimal strategies. There is no next chapter. This is the end of the road for this semester. I hope that the transition from Dr. Kim to me and from in person to online wasn't too stressful. Hope everyone takes it easy, stays healthy. Thanks for making this as easy as possible for me.